Have you ever wondered why some things heat up quicker than others? Or why some substances might take several minutes to get hot, while others only take a few seconds? It is well understood that as heat is applied to a substance in a single state, the temperature of the substance will increase. Experiments have proven that some substances can be heated more easily or with less heat added than other substances. The term scientists and engineers use to describe this material property is specific heat. Specific heat is defined as the amount of heat required to raise the temperature of a substance by 1 degree. In the United States, the customary unit for heat is BTU, and for temperature, it is degrees Fahrenheit. So, specific heat is the amount of BTUs required to raise 1 pound of a substance 1 degree Fahrenheit.
Specific heat is a very important topic to understand in refrigeration. When I'm explaining it to someone, I always like to introduce them to water because water has a specific heat of 1 BTU per pound degree Fahrenheit. That means that everything else can be compared to water. And since we're so familiar with water, that becomes a helpful baseline. So anything that has a specific heat like greater than 1, significantly greater than 1, is a good insulator. It doesn't transfer heat well. That's good for building materials, insulation in walls and roofs and so on, and pipes. Anything with a specific heat less than 1 is exceptional or better at transferring heat. So metals tend to be very good. Very low specific heats are good at transferring heat, which we know from experience as well. So using water as the baseline gives us a sense of the specific heat value of any given substance.
Here is a listing of some specific heats for some common materials. As you can see, iron will heat up quicker than water because it has a much lower specific heat. The major takeaway is that materials with a low specific heat are easy to heat or cool. On the flip side, a material with a high specific heat is difficult to heat or cool, making it an ideal insulating material.